National requirements often drive extreme aircraft characteristics. The U-2 overflew Moscow and was seen on radar, and pictures showed surface-to-air missiles being deployed. President Eisenhower directed that a new aircraft be created, not flying at 450 miles an hour, but 2,150. Not at 70,000 feet, but at 85,000 feet, and would be America's first stealthy airplane. When you're flying an airplane at Mach 3, the surface temperature will exceed 600 degrees. The airplane will grow 3 to 4 inches in length, an inch or two in width. Aluminum can't be used, so 93% of the aircraft is made of titanium. Special fuels had to be created, JP7, to withstand the high temperatures. Normal fuel has a flash point of minus 40 degrees. JP7 is a plus 335. Electric ignition would not work, so the chemical triethylene borane, which explodes at 3,000 degrees, is used to start the engine and to light the afterburners.
For millennia, humanity has wanted to reach into the heavens, to fly above the planet. We have seen this in numerous instances throughout our history. In Greek mythology, Daedalus and Icarus fashioned wings of feathers and wax to try to fly. Leonardo da Vinci sketched flying machines and helicopters in his notebooks. In 1783, the Montgolfier brothers were the first to build a hot air balloon that successfully flew. In the 1890s, Otto Lilienthal built gliders, and in 1903, the Wright brothers built the first powered aircraft that was practical.
The Space Shuttle was designed. The goal was to create a reusable orbiter that could be used again and again to lower the cost of spaceflight and to avoid having disposable spacecraft. And so the wings are another indicator of that, because the spacecraft had wings and could glide safely to a landing on Earth. It could be serviced on the ground and could fly again. And in fact, the 5 Space Shuttle orbiters flew a combined total of 135 missions over a 30-year period. That, too, had never been done before.
One of the most interesting but perhaps less known spacecraft in history is something called Pioneer 10. It was launched from Earth in 1972, the same year that astronauts last walked on the moon, and it went out to the outer planets. It was the first man-made object to leave the solar system.
If you take a look at the Wright Flyer, if you take a look at airplanes during World War I, what do you see? You see airplanes that are basically vegetable airplanes. They're made out of wood and out of fabric. They're vegetable airplanes. However, during World War I, there was a breakthrough. A man by the name of Hugo Junkers in Germany wanted to design an all-metal airplane. He needed to do something important before he could do that. He needed to have a thick wing, a thick airfoil.
The gull wing on the F-4U Corsair was the result of a design process by Vought engineers that really began with the selection of the engine. And Vought engineers wanted to use the most powerful engine available, and that was the Pratt & Whitney R2800, a 2,000 horsepower class engine. And so once they chose the engine, they realized that we need to have the largest propeller possible to get the maximum amount of performance out of this engine.
Beginning of the 21st century, the Predator drone changed the nature of air warfare. Before, military air operations were very complex. Aircraft would have to go out, photograph and document an enemy target. They would bring that information back, had to be processed and interpreted. Missions had to be planned. Aircraft sent out on strikes. Other aircraft would go out and document whether those strikes had been a success. That process might take days or weeks. What the Predator does is it does that in real time, and it can do it with it being controlled from the other side of the planet. This has completely transformed both international relations and modern military operations.